Now that we've created our load circuit, let's go and create our nMOS NOT or inverter gate. First off, we'll start off with the construction. Model it. We've got our VDD. We've got our mandatory resistor. We've got our nMOS. We're going off to ground. We're putting a signal in here, and out pops our answer here. The equation is Q equals A knotted. The truth table is A and Q. When A is 0, Q will come out 1. When A is 1, Q will come out 0. Remember, 0 is a low voltage, about 0.8 or lower, and 1 is about 2 volts or higher. So answer comes out Q here. Here's our resistor, and our answer, our variable A goes in here. For the diagram, we've got our logic. Out pops the answer Q, and we'll do our load circuit here. So when Q is equal to 1, LED is equal to on. So let's go now and construct this in Multisim. With Multisim open, what we'll do is make sure we save everything from previously. We go File, Save As. We're in the load area here, and we go nMOS NOT. Save that one. We'll minimize that for now. And what we need is what we'll do is just copy that one. That's Q NOT. Okay. We need another resistor. And we'll use the existing switch. So I'll speed up the video now and tidy all this up and get it working. So, a quick summary. This is our control area for the switch A. When the gate is closed, we apply very little voltage, or basically 0 voltage at the gate. The NOT changes it from 5 volts, 0 volts, almost a 0 volts, or a logical 0, to a logical 1, or spot on 5 volts. And then we use it to drive our circuit here to switch the LED on. As the LED is on, we'll place place a comment, graphic text there. LED on when Q equals 1. That'll do for now. So let's go about this and update our breadboard. Right, now I'll open up my image. So what we've got here is our nMOS and a resistor. We've got our load switch from what we created previously. We've got a button. I'll switch on the board. When the light is on, off, on, off. What we're going to do is now construct our NOT gate, nMOS NOT gate. And I'll take my time and I'll probably speed up the video quite a bit and see how we go. Right, everything's done now. So we've got our multimeter connected to the gate A. When the button is not pressed, we're applying 5 volts at the gate of the nMOS. And then we drive our circuit, and as you can see, 5 volts or 1 equals 0. When we press a button, we're applying virtually 0 volts at the gate, and this equates to a NOT of 1, so the LED is on. If we go and look at our circuit, we'll simulate it again. Here the button, or the button isn't, how would you say? Here the switch is in its off position or not pressed. So we're applying 5 volts at the gate. And as you can see, we've got 5 volts here. When we, the LED is off, and when we close it, we've got the LED on. On, off, on, off. Thank you very much.